Now student, we calculate the percentage of sulfur in sulfuric acid, H2SO4. Okay. Here we calculate the percentage of sulfur in sulfuric acid. Okay. So we have to calculate the molecular mass of sulfuric acid equal to 2H plus 1 sulfur plus 4 oxygen. Okay, so 2 into 1 plus 1 into 32, that is the atomic mass of sulfur is 32. Okay, atomic mass of hydrogen is 1 and 4 into 16. Okay, atomic mass of oxygen is 16. That is 2 plus 32 plus 64. That is 98 unit. Okay student, so molecular mass of sulfuric acid is 98 unit. Clear? Now we calculate the percentage of sulfur in sulfuric acid equal to 32. Here oxygen is, atomic mass of oxygen is 32. So 32 into 98 into 100. Okay, that is 32.65%. Here sulfur is 32 amount, 32 unit among 98 unit. So percentage of sulfur in H2SO4, 32 by 98 into 100. 32.65%. Clear? So student, we can calculate any element present in its compound, and so we can calculate its molecular mass also and its percentage in its compound. For example, chromium, percentage of chromium in K2Cr2O7, that is potassium dichromate. For this we have to calculate first the molecular mass. So molecular mass of potassium dichromate, here 2K plus 2Cr plus 7O. So now we put the atomic masses of each element. Potassium atomic mass is 39 and here 2 potassium atom. So 2 into 39 plus 2 into 52, atomic masses of chromium is 52 and 7 into 16, that is 78 plus 104 plus 112, and that is 4, 8, 4, 12, 2, 4, 14 and 29, 294 unit. Okay student, now we calculate the percentage of chromium in K2Cr2O7, 104. Here chromium is 104 unit. Okay, so percentage of chromium in H2SO, potassium dichromate, that is K2Cr2O7, is 104 by total mass of the compound into 100, and it will be 35.37%. Okay student, so we can calculate mass percentage of element in the compound. Okay, and The formula is mass of the element by the total mass of the compound into 100. So percentage of element in the compound equal to mass of the element divided by total mass of the compound into 100. Okay, student. Now, student, we calculate the empirical formula and molecular formula of a compound. For example, a compound has 93.70% carbon and 6.29% hydrogen. If its molar mass is 128 gram, mole, calculate its molecular formula. Okay, student. So a compound has 93.70% carbon and 6.29% hydrogen. If its molar mass is 128 gram mole, then calculate its molecular formula. Okay. So student, for this we have to calculate first the relative number of atoms that present in the compound. Okay, for this we take the elements. At first elements. Okay, here two elements. One is carbon and another is hydrogen. Okay, now percentage of carbon here 93.70% and percentage of hydrogen is 6.29%. Okay, and atomic mass of carbon is 12. Okay, and atomic mass of hydrogen is 1. Clear? Now student, we calculate the relative number of atoms. Okay, here relative number of atoms calculated by total mass by molar mass. So molar mass of carbon is 12. So it will be 7.80. Okay, and relative number of atoms of oxygen 6.29 by 1, that is 6.29. Okay, now divide by least. We have to take in among these the least numbers. So for this 7.80 divided by 6.29. Here 6.29 is the least number. So we divide this with all the ratios. So 7.80 by 6.29, that equal to 1.25. And here 6.29 by 6.29 equal to 1. Okay, student. Now, student, we have to make a simplest ratio. Simplest ratio, because here 1.25. We have to make this in a simple ratio. For this, if we multiply this with 4, we can get 5. Okay, and 1 into 4, that is 4. Okay, so empirical formula equal to C5. Here carbon is 5, okay, and hydrogen is 4. So its empirical formula will be C5H4. Okay, student. So this is the calculation of empirical formula. Okay. Now we calculate the molecular formula. For this we have to find out the numbers, that is n. That is n equal to molecular formula weight by empirical formula weight. Okay, here n equal to molecular formula weight by empirical formula weight. Okay, so student, empirical formula weight, now we find here the empirical formula weight of C5H12 equal to 5 into 12 plus 4 into 1, that is 64. Okay, now put the value. So molecular formula equal to n into empirical formula. Empirical formula. Okay, so here n into C5H4. Here value of n So student, now we put the values of molecular formula weight, that is 128, that is given in our question. Okay, 128 molecular mass. And the empirical formula mass we get here 64. Now 128 by 64, that is 2. Okay, now put this value n into C5H4, n into empirical formula. Okay, so we get value of n here 2 into C5H4, that is, it will be C10H8. 8. Okay, student. Student, now we discuss about limiting reagent. Limiting reagent, the reactant which is entirely consumed when a reaction goes to completion is present in a smaller amount than the calculated amount. Okay, so student, the reactant which is entirely consumed when a reaction goes to a completion is present in small amount than the calculated by balanced chemical equation. Okay, and excess reagent, the reactant which is not completely consumed in the reaction is called excess reagent. It is present in a larger amount than the calculated by balanced chemical equation. For example, here hydrogen and oxygen react and they form water. Okay. Here 4 gram hydrogen react with 32 gram oxygen and we get 36 gram of water. Okay. So 4 gram of hydrogen react with 32 gram of oxygen and 3 gram of hydrogen will react with 24 gram of oxygen. So here hydrogen is limiting reagent because it is being entirely consumed. Okay. So amount of oxygen left 29 minus 24, that is 5 gram. So oxygen is not consumed completely. Therefore it is an excess reagent. Okay. So oxygen here is excess reactant. Clear? Now student, we discuss about molarity. Molarity, it is defined as the number of moles of solute dissolved per liter of solution. Molarity expressed by capital M. Okay, and it is defined as moles of solute dissolved per liter of solution. Okay, and molality, it is expressed by small m, and it is number of moles of solute per 100 gram of solvent. Okay, so molarity is defined as the number of moles of solute dissolved per liter of solution, and molality, it is the number of moles of solute per 1000 gram of solvent. 1000 gram of solvent. Okay. Now student, we calculate molality and molarity. Okay. So student, for calculation of molarity, look at here. Molarity of sodium hydroxide we have to calculate, and the solution prepared by dissolving 4 gram of 4 gram in enough water to form 250 ml of the solution. Okay, 250 milliliter of solution. So we have to convert this 250 milliliter of solution into liter, because our formula of molarity is number of moles of solute by volume of solution in liter. Okay, so we have to convert 250 milliliter into liter, that is 0.25 liter. And number of moles of solute is mass of sodium hydroxide by molar mass of sodium hydroxide. Mass of sodium hydroxide is 4 gram and molar mass of sodium hydroxide is 40. So number of moles of solute here 0.1 mole. Okay, and volume of solution in liter 0.250 liter. So that is 0.4 molar solution. So the molarity of sodium hydroxide is 0.4. Okay. Now student, molality. Molality, equal to number of moles of solute by mass of solvent in kg. Okay, so here the density of 3 molar solution of sodium chloride is 1.25 gram milliliter. Okay, and calculate the molarity of the solution. Here M equals to, that is capital M, molarity equal to 3 mole per liter, and mass of sodium chloride in 1 liter of solution is 3 into 58.5, because molar mass of sodium chloride is 58.5, so it will be 175.5 gram of mass. Now we convert 1 liter of solution, 1.25 gram per liter of sodium chloride. So in 1 liter of solution it present 1000 into 1.25, okay, and it will be 1250 gram, 1250 gram. Okay, now mass of water in solution, 1250 minus 75.5, that is 1074.5 gram. Okay, now molality equal to, we know that number of moles of solute by mass of solvent in kg. So number of moles of solute will be 3 mole and mass of solvent we know 1.075 kg. Okay, and dividing this we get as a result 2.79 small m, that is molality. We express molality by the small m and molarity expressed by capital A. Clear? Now student, from your exercise practice all the sums on molality and percentage compositions. Okay, empirical formula, molecular formula, practice all the sums. Okay student.